Good morning, everybody. Happy St. Patrick's Day. I'm all decked out and see if that makes it any better. Oh, there we go. Okay, sorry guys if we lost you. We had some internet issues. You know, aren't we all having issues right now? So whatever. Anyway, so the first experiment we're gonna do is called Leprechaun Toothpaste because St. Patrick's Day. So we're gonna make some toothpaste for leprechauns. So this is not the one that we gave you guys the ingredients for. We're gonna do that one second. This one is just gonna be a watch and learn, but then after we're finished, we're gonna put the instructions and all the supplies that you need in the comments so you can pull those up and do this one at home after we're all done. So lots of fun projects that we're gonna get to that you'll be able to do all of them, but they, let's see. Oh, good morning. Oh, I saw it. They said hi. We have someone too that said hi. Oh, Pablo and Daniel said hi. Hi, Pablo and Daniel.
Hey guys.
We're glad you guys are watching with us. So sorry, I apparently should be wearing my glasses. We're good. Okay, so this one is called Elephant Toothpaste, and this is, as all of these experiments are, chemistry. So, Mr. Austin, can you tell us what chemistry is?
So the chemistry is the reactions between different types of physical matter in the world. Who can tell me, if you're listening along, what are the three types of matter?
You matter, Austin. We all matter. Yeah. That's the type of matter that matters. Let's see, I can say there's liquid. Good. Does everybody know that one? Liquid's a matter, right? Good. What's another one?
Solid.
Solid is okay. So liquid is drinks, your sodas, your water that comes out of the faucet, right? Let's see. Oh, we have some more. Oh, good morning. Oh, hi, Zoe. Okay, and who else do we have here? Oh, hi, guys. Okay, sorry. I don't have my glasses on. I can't see. Can you see those? Oh, Daniel said solid, liquid, and gas. Oh my gosh, good job, Daniel. You beat us to it. We didn't even get to it. So
very good.
That's exactly right. So solid is anything hard, right? Mm-hmm. You're solid. Wall's solid. Plastic is solid. And then liquid is anything liquid, anything you drink comes out of the faucet. And then gas is air, like the air in a balloon, clouds in the sky, right? Those are mostly gas, right? That kind of thing. Oh, let's see here. Oh, good morning, Joshy. Sorry, I'm gonna do this the whole time, Austin. Sorry. Okay, so we're gonna do a chemistry experiment now. So let's see. We've got Leprechaun Toothpaste here. So tell us, what supplies are we using here, Austin?
All right. So I've got already in this cup is 4 ounces of warm water. Warm water. So I've got. 4 tablespoons of warm water. And
like I said, we're going to put all the supplies in the comments, so don't worry about having to write this down as we go.
Yes, and then I've got my yeast here.
That's just regular yeast like you would buy at the store, like to make bread or something like that.
I've got some green food coloring because it's St. Patrick's Day and it's just good fun.
Not that everybody was aware of that.
We've got some dish soap.
Regular dish soap that you'd use to wash your hands.
Yep.
Oh, hi Hannah and Travis.
And then I've got some special peroxide. So this is 6% peroxide. You might need to go to the salon store to get it. You can still do this experiment with regular peroxide that you buy at the pharmacy. It's just your reaction will not be as dramatic. So I would recommend if you have the time or the ability, go out and get some of this from the salon store.
Yeah. But otherwise, regular peroxide will work, and then later, if you want to do it bigger, you can do it with the industrial strength stuff. Or maybe you have somebody who does hair and they already have it on hand, or for some reason they have it. So again, this is why we didn't put the instructions out this ahead of time. So let's see here. Oh, hi Asher.
Hi.
Okay, you guys get ready for the fun. Okay,
all
so
right.
we've got just an empty water bottle. It could be a soda bottle, any kind of plastic bottle. Yep. Ideally a plastic one that you can throw away, right?
Yes, and a wide top too, just to make it easier to pour things into.
Very good.
All right, so next I'm gonna do is, so like I said, I've already got my 4 tablespoons of warm water in this cup. So now I'm just gonna measure 1 tablespoon of the yeast. That's about a tablespoon.
1 tablespoon, good. So the yeast goes into the cup that has the warm water in it already. Okay.
Yep. And so now I'm going to, does anyone know what happens when you add yeast in water?
I do not know what happens when you add
yeast. It kind of clumps up like you would if it were flour or something. So a big part of this is just giving it a good mix. Maybe I can I don't know how well they can see. Yeah. See how it's kind of lumpy in there? I still need to keep stirring a bit because we want most of those lumps to be gone. So it might take a second here.
So while you're mixing, I'm going to point out that we are wearing gloves. We did wash our hands ahead of time, but we're still wearing gloves just to be careful. Anytime you're doing any kind of experiments or anything, you always want to be safe. So got gloves on. Austin's got his nice protective glasses on because you always want to protect your eyes. Make sure that they're totally safe. We also have a little tray on top of our table. If your mom says it's okay to do it right on the counter, you can do it right on the counter, but you're gonna have to clean it really good. So you can use a tray, you can use a cookie sheet, something like that that can be washed is good. Also, we have a tarp down because we're in our office and we're not really supposed to be doing chemistry in the office. So we've got a tarp down, so we're fine, but I might suggest doing this in the kitchen or in the bathroom, somewhere
with
like,
hard floor.
Yeah, a hard floor that can be easily cleaned up just in case, because we're going to make a little bit of a mess. Okay, I'm seeing lots of more friends saying hi. I don't think I can't get to everybody here who's saying hi. Okay, I think Gunnar is the most recent one. Hi guys, we're so glad you're watching. Okay, I hope you're ready. Okay, so Austin's got us all mixed up, so our yeast and water is not lumpy.
So we've got our yeast and water solution. We're going to set that off just to the side just for a minute here. And now we're going to add the other stuff here. So I'm going to add a little bit of this food coloring, like I said, green for St. Patrick's Day. So
obviously, leprechauns wash their teeth with green toothpaste. What else would they use, right, guys?
Absolutely. And so then we've got, and again, you can kind of eyeball this, but it just calls for a few drops of the dish soap. So
it doesn't matter what brand of dish soap you use. So we're using the cheap stuff because we don't want to waste the good stuff. Just a few drops. More or less, you can. That's one fun way to try these experiments. Is you can do it one way using just 1 or 2 drops, and then do it again using a whole bunch and see the difference that it makes. And so that's what scientists call that the scientific method, where you test different theories. So you just change one variable and see how it changes. So that's one way to go. Okay, now we're mixing in the hydrogen. No, the peroxide.
Yeah, the peroxide.
Sorry.
Yes. And so I'm using a funnel just because.
Good. And that was a half a cup of the peroxide.
Yes. Yeah. Sorry about that.
That's okay.
Half cup.
I was talking. You're good. Okay. So
all right. And
in the bottle now. There we go. Here's our green bottle. We've got food coloring, a half a cup of the peroxide, and a few drops of the dish soap. Okay. So what do you guys think is going to happen next? Anybody have any ideas? I think Austin's going to drink it. What do you think? No, Austin's not going to drink it. Okay. All right. Well, I'm going to put on my safety glasses too. So, all right.
wow.
I mean, it's St. Patrick's Day. It's St. Patrick's Day. So, all right, Austin, what's next?
Next, we're just going to take our 2 solutions that we made, and we're just going to mix them together and see what happens.
Oh, man. Okay, here we go. Ew, gross looking. Oh, and look at that. We are making a giant mess. You guys see it bubbling and bubbling? This is why we have a tarp down on the office. Okay, so Austin, tell us what is happening here.
All right, so we added a bunch of different types of, we had a solid, our yeast, we had some various types of liquids, and what happened was we had all these different chemical reactions going on, and the yeast, the reason why the yeast is so important is the yeast acts as a catalyst, meaning it speeds up a reaction. So that's why whenever all the things went together, this happened really, really rapidly. Go ahead and...
Look, can you guys see, look how fast it's still coming out.
Yeah.
It is still coming out. It kind of looks like toothpaste.
Yeah, and since you've got your safety, your gloves on, would you mind go ahead and feeling that foam and tell me kind of what it feels like?
Sure, I'm guessing it just feels like regular, like toothpaste or something. Oh, okay, so it's kind of fluffy, and it's thicker than I expect, because it's warm. It's really warm. Is that because the water was warm, or why is this so warm?
So part of the reason why that...
Oh, it's hot. It's actually hot.
Yeah, part of the reason the temperature heats up a bit is so since we had all those reactions happening so quickly, all those molecules rubbing together creates a lot of friction type thing, and it heats up the foam and everything. So sorry to give you a little more of a warning. But,
that's okay. It's not too hot that you would burn yourself. So if you're playing with this at home, you're totally fine to touch it. But it's definitely warm. It's like bathwater warm. It's just surprising that it is so warm because the water was not that warm when we started with it. It definitely warmed up from where it was. But otherwise, it's like foamy. It's almost like whipped creamy, sort of like it holds the shape a little bit, but it's fun. This would definitely be a fun thing to do on a big cookie sheet and smush your hands in it and make a big old mess. And I would not recommend like rubbing it on your brother's face.
Nope, let's not do that.
Don't do that. Don't do that. We're gonna be friends. We're gonna be nice. We're gonna social distance with our phone. So there we go. Okay, so like we said, guys, that was that was a chemical reaction. That's what chemistry is. Like chemistry sounds like a big, scary, crazy big word, but chemistry is just mixing things together, and then because of what they're made of, stuff happens. Right, Austin?
Exactly.
There you go. Clearly I'm a science major here. All right, so are we ready for another experiment?
Yeah, I think we can go ahead and move on to the next thing.
Okay, guys, we're gonna move this one out of the way here, and we're gonna go to the next one. We have assistant stuff. Let's see here. Oh, Isaiah says hi. Yay! Okay, Isaiah, you definitely should do this at home once we finish. We'll put all the instructions, like I said, in the comments, and you can totally do this at home. So obviously we just cleaned up after we're finished. You want to clean up as you go. It's an important part of being a scientist is to keep things clean. Yeah, I'm gonna take my gloves off. I'm getting yelled at for my gloves. I'm still talking. So you want to keep things clean. You want to have fresh gloves. And part of it is so that your mom doesn't get mad at you and lets you keep doing it. And part of it is because if we had stuff left on the table and it interacted, then it would mess up our experiment. Like earlier, Austin screwed up. And so
Throw me right on the table.
Yes, I did. So same funnel for one thing and the other, and then when he was using the reaction started in the funnel because it still had some remnants of one of the ingredients. So that's the kind of thing you always want to, as a good scientist, that's why you always see scientists with the coats and the hairnets and like all the sterile environment, because you got to keep things clean so that you don't have any weird reactions. Okay guys, so we are going to do the experiment that we told you to get the supplies for. So if you want to do it along with us, get your stuff ready. Otherwise, you totally can wait until we're done. And like I said, all the instructions will be in the comments. And you can, let's see. Oh. Hi Isaiah. I think it says Isaiah there. Oops. Oh, Ishala. Hi, Ishala. Sorry, guys. We have lots of moving parts here going on. Okay, so if you're going to do this with us, you got to get your water bottles ready. Again, if you want to put it on a cookie sheet or some kind of tray or safe thing, or if your mom says it's fine wherever you're working, that's totally fine too. Okay, and then we've got an uninflated balloon, and then we told you to have baking soda and vinegar. So if you have that and you're doing it with us, we already have the baking soda inside our balloons, okay? And we did that just to be faster and to be easier. But how much baking soda are we using, Austin?
We're using 2 tablespoons.
2 tablespoons of baking soda. So if your mom or dad or babysitter or grandparent is there, if you have an adult there that can help you, they can open the balloon like this and either use a funnel or use a spoon or something and put 2 tablespoons of baking soda inside the balloon right now. If they can't do that or that's too complicated or whatever, you can also totally put it in the cup, right? And then you do it afterwards?
Well, the reason why...
you do the vinegar first.
We have the vinegar in the bottle.
Okay. So I'll tell you when we're doing it the second time if you don't have it already in the balloon. But if they can go ahead and do that right now while we're waiting, that would be the easiest way to do it, because then you can do it just like us. Like I said, we did this ahead of time. We cheated because we wanted to be ready to be able to do this faster for you guys. Okay, so water bottle, vinegar, baking soda in the balloon, gloves, mask. If you don't have gloves, you can wear sunglasses. Totally works, right?
Yeah.
Yeah. And the gloves are okay. The gloves are better to have, but if you don't have gloves, it's okay if you don't have gloves. But definitely, once everything starts reacting, don't touch your mouth, don't touch your eyes, don't touch anything until you wash your hands again, just to be safe. Okay, so awesome. Let's go. What's next?
All right, so we're now going to we're going to add our vinegar to our bottles.
Okay.
So the experiment calls for 4 ounces of vinegar. But what we're going to do, since this is a 12-ounce bottle, we're going to fill it about 1/3 of the way because, well, 3 times 4 is 12, so that's roughly here-ish. And so we're going to fill both of our bottles up to about...
Hi, Braylon. So Austin, again, is using a funnel. If you have a funnel for the kitchen, that's great. If you don't have a funnel, that's also totally fine. You can just pour it very gently.
That's a little more than I thought.
So again, the 4 ounces is not totally exact. More of any ingredient will have more of a reaction, like we talked about with like the yeast and the other things. Oh, hi Charlie. If you end up pouring a little bit more, that's totally fine. Don't feel like you need to like measure it perfectly exactly. We're trying to get it about 4 ounces because that's where we have the best results. But again, that's one of those things where you can experiment with later. more supplies, then try it again using lots of vinegar, and try it again using just a little bit of vinegar, and see how that changes your experiment, and then that'll give you a better idea of what the reaction does. Okay, so 4 ounces of vinegar in our water bottle. Smells delicious. Anybody who's doing this at home, you know what I'm talking about. Love vinegar smell.
Exactly.
Thanks.
And just quick thing too, anytime we're doing any type of chemistry, another safety thing, if you ever have any kind of chemical in a bottle like this, do you think you should hold that thing right up to your nose and just take a big old whiff?
No.
No, because even though this is just vinegar, so the smell isn't super nauseous, but other types of chemicals could be, especially certain types of cleaners. So if I want to get a better smell of this vinegar, even though I don't need it because it's very strong, what I'm going to do is I'm going to hold it in front of my face like this, and I'm going to waft it. And that will give me a little more smell of the smell. So like I said,
disgusting. But it could be dangerous.
Yes. So
not necessarily the vinegar, but
not
other
the vinegar, but other types of chemicals could be. So very important. We're always smelling things by wafting.
All right, I'm gonna waft it that way. You can smell it for me. I'm good. Thank you.
Cool. Well, are you ready to get going?
I'm totally ready.
All right. Who thinks? So do you think your balloon's gonna be bigger or mine?
Well. So what do you think is going to happen here? So we're going to attach the balloons on top of the water bottle is what we're going to do? Mm-hmm. Okay, and then what's going to happen when we put it on top?
So we're going to go ahead and fix this over. And
so just put it on top, leaving the balloon hanging down.
Yeah, but you see how you've got it hanging out to the side, so nothing's going to happen yet.
Good.
Next
and
thing...
we want to try and get the balloon all the way, see how it's all the way down there? So it's on there really, really tight. Good.
And you'll see why that's important
but
in
it's
here.
Still hanging on there. Good.
And then here in a second, I'm going to go ahead and tip this part of the balloon over so that my baking powder will flow into the vinegar. Go ahead and hang on to the bottom of this balloon fairly tightly.
This bottom right here where it attaches. And so this is the part where if you didn't get your balloon preloaded already with the baking soda, then you would be just pouring the baking soda in and then putting the balloon on really fast. But you just have to move really, really fast if you're doing it like that. Exactly. So, like I said, that's why we put it in the balloon ahead of time. But you can do it. You can totally do it if you can. Okay.
Hi.
What is it? Nash. Hi, Nash. Okay, you ready, Nash? You guys ready? All right. So we are going to hold on to this, and we're going to. Does anybody have any ideas of what's going to happen when we straighten the balloon up? No? Think it's going to explode? Is it going to explode?
It shouldn't.
Okay, good.
It's why I wear the safety glasses.
Good to know. Okay, great. All right, here we go. Ready?
Yep.
Go. Okay, all right, so we're shaking it a little bit. Oh, look at that. Watch it blow. Oh my goodness. Okay, so it's blowing out, and this is why we're holding on tight to the thing. Yours hasn't even gone in all the way. Oh, well, I'm totally winning this race. So look at that. Oh, I have like a pear-shaped balloon too. That's fun. Okay, so Austin, what is happening here science-wise? What is going on? Because there was not enough air in this water bottle to all of a sudden blow up this balloon.
All right, so kind of like what happened on the last thing was where we had various different types of matter interacting together. Here we've got a solid, which is our baking powder or baking soda, and we had a liquid, which is our vinegar. And when those two things react together, their byproduct is a gas, which is in this case CO2. And CO2 is a gas. So when you have the baking powder and the vinegar reacting together, their byproduct is baking soda, excuse me. The baking soda and the vinegar, their byproduct is carbon dioxide, which is a gas. And so when those two things got together, the gas blew up our balloons.
It totally did. So the first experiment we did with the toothpaste was with yeast, and what were our ingredients in that one? Do you remember? Yeast and soap and baking soda still? Oh, the peroxide.
Yeah.
So the reaction of those made the foam, but the reaction of the baking soda and the vinegar makes the gas. So it depends on what kind of ingredients you're using for that makes a difference of what sort of reaction and what your result is. So now this is what is the air inside here? Is that like regular breath air?
So when we're breathing, when you exhale, you're exhaling carbon dioxide.
No, got it. I got it.
Yeah. So when we exhale, when we're breathing, we take in oxygen and we exhale the carbon dioxide. So this is much like if you were to have blown this balloon up.
Smells terrible. Don't do that. I was wondering if it smelled like vinegar. It does. It does smell like vinegar, and it kind of splattered a little bit at me. So don't do that.
Yeah.
Let's see.
Point our balloons in a safe direction.
Hi, Hudson. Don't smell your balloon, Hudson. Yeah. Oh, you can though. You can make sounds with it. Oh, ooh, look at that. sorry. But we could totally tie it, right? And then because it's
you could tie it and just have a balloon.
Yeah.
Look at that.
So this is full of gas. So this is not the same gas necessarily that's in the air that we breathe, or is it?
So there is a lot of carbon dioxide in the air, the ambient air here. But a lot of I think about 25% of the air that we breathe is carbon dioxide, with other types of gases mixed in. Oxygen, of course, being one, and some nitrogen too. So
very good.
I forget all of the exact amounts of things,
but carbon dioxide is what plants breathe, right?
Yep. And so carbon dioxide, plants will take in that carbon dioxide to make the sugars and stuff that they need to get them by.
So should we like hold our balloon over like our flowers and give them a breath of air?
You can try it.
They probably wouldn't like it. They probably don't like the vinegar smell either.
Oh,
flowers smell good.
We'll say that experiment for the next Facebook Live.
Oh my goodness, very good. Let's see here what happened. Oh, Bentley in Boston. Hi, Bentley in Boston. Did you guys see our balloons? Yeah. Don't blow them in your face. It was not a good thing. But it was really fun. It was a really fun thing. And like I said, so you can try this again and put more vinegar in and see what happens. What do you think would happen? So what do you think would happen if we filled the vinegar all the way up to here?
Well, it depends. So you've got these things in chemistry called limiting reagents. So there's an optimal amount of baking powder and vinegar that will give you the biggest reaction possible, or in this case, make the biggest balloon possible. Well, sometimes, so if you have a 90% baking powder and only 10% of it is vinegar, your reaction's not going to be very big. Baking soda. I keep calling it baking powder. I mean baking soda.
It's fine.
Arm and Hammer. Yeah. Well, if you went the other way, where you used a whole lot of vinegar and hardly any baking soda, again, your reaction would be very big. So you got to find somewhere in the middle. You want about the correct amount. And then, according to our procedures here, about the optimal amount for the biggest reaction is going to be 2 tablespoons of baking soda and 4 tablespoons of vinegar.
So what Austin means is everything in moderation,
yeah.
Right? You can add too much of a good thing. Just like cookies are delicious, but then if all you eat is cookies, you're gonna get sick to your stomach. So.
But I mean, if we
got it's still fun to play with. So it would be
exactly.
fun to try just a little bit more, a little bit whatever, and just see how it goes. That's a good way to really get into chemistry and stuff, is to see how changing one little variable changes something else. So again, like everything else, we're gonna take off our gloves. We're gonna move all of our stuff, clean out our space, so that we don't have any sort of bad reactions to our next experiment. Okay, so we're gonna do one more experiment. We have time for one more experiment, and this one is not as messy. Oh, this one is.
Well, it can be messy, but
okay,
it just kind of depends.
This is a fun one. Okay, so this one we're not gonna do it messy because we already done it, so we're not gonna get messy. But when you guys do it, y'all are gonna get messy. So, so we're gonna show you what this is and how it works and the chemistry behind it, and then we're gonna give you the instructions so you can make one of these at home. This will be a fun project to do this afternoon. But right now we're just gonna talk about. Okay, so we're talking about lava lamps, which your mom probably knows about. You guys maybe don't know about, but your mom maybe had one in her bedroom when she was a little girl. So, Austin, let's start.
All right. So what I have already pre-made is the lava lamp, so to speak. And so I'll hold that really close. So that is just a mixture of water and oil, essentially, with some glitter and stuff in there too. So,
so what kind of oil is this? Baby oil? Is this like vegetable oil, Trina? Mineral oil. Okay.
Mineral oil.
So mineral oil is, thank you for our helper. Miss Tiffany is our helper behind the scenes today. So mineral oil, you might not have at home, you might have it at home. People used to use it like as medicine a lot, but you can still get it just at the regular grocery store. We actually use it at our house for the countertops, like they're wood countertops, and you're supposed to like moisten the countertop. I don't know exactly. Either way. Mineral oil is what we're using. Okay, and sometimes a little thing like that can make a big difference, and that's where we were talking about with the chemistry. The different materials can have different reactions, so we probably don't want to try this with vegetable oil because it would probably have a different reaction. Although you could totally try it and see.
See how it works.
Yeah.
Yep. So the big thing here is we've got the heavier parts of this mixture settling down here on the bottom, and the more liquid parts are up here on the top. So. That's what gives you that cool separation, very clear where the white ends and the clear begins. But so what we're going to do next is, since we have our lava lamp built.
So this is just any kind of regular jar, like a mason jar kind of thing. Could you do this in like a plastic bottle, like a soda bottle?
Yeah, you absolutely could.
Okay, so any kind of container that you can do, you want it clear so you can see, because that's the fun part. This looks like this has glitter in it also. I think they maybe added glitter just for the fun of it. So you can add whatever kind of little glitter or sprinkles in it that you want for fun, just to make it more interesting.
Cool. So what I've got here.
Side of the thing.
Oh, okay.
Oh, just the whole table. There we go.
Oh. And so what I've got here.
There we go. All right, we're getting a close up here so we can see our bottle. This is our lava lamp bottle here. Okay,
so what I'm crushing up in my hands here is just an Alka-Seltzer tablet, and what I'm doing is I'm crushing it up best I can with just my hands.
Still in the package.
Still in the package, yeah. And then I'm gonna go ahead and pour that guy into the jar here.
So Alka-Seltzer is something that like your parents would have like for an upset stomach or heartburn kind of thing. Not Tums, right? Tums wouldn't work the same. We want Alka-Seltzer. The kind that you put like in water and then you drink it after it bubbles up, that kind of heartburn medicine. Again, this is all stuff you can get at the grocery store or dollar store, whatever kind of store you're at. So okay.
Pour that guy in there.
Okay.
So I'm not gonna.
Don't pour the package in, guys. Don't do it.
Cool.
Okay. Oh, okay. Can you guys see what is happening here now with our lava lamp? Let's see here. Okay. There we go. There we go. Okay. So look at all those little reactions. If you guys can see, we've got little bubbles coming up and down. Let me see if I can move a little bit closer here. There we go. Look at all of that. Isn't that crazy? So what is going on in there, Austin?
So we've got the Alka-Seltzer interacting with this bottom layer here. And what it's causing there is and that reaction is causing gas to form. And that's what's making these little bubbles. So these bubbles are now all floating up to the top and congregating and collecting together. So that's why we're kind of starting to have stuff up here on the top.
Okay, Paxton and Grayson are watching. What do you guys think about this, guys? So this is a fun thing. Again, you can try it at home if you're done. What would happen if you shook it up, Austin? Would it do anything?
Let's see. Might speed it up a little bit. But for the most part, it looks like, there's some more.
Oh, look at that. Wait, push a little bit lower there.
Oh, sorry. Getting away from the camera.
You're good. Look at that, guys. It looks like it's like another planet or something. Like, doesn't it? It looks like the surface of the sun or something is what I imagine. It's like...
Take the lid off.
Okay, so Miss Tiffany says we can take the lid off. I'm going to say an adult needs to do this if you're doing it at home. Oh, interesting. Okay, so now we take the lid off. Nothing is exploding, but we can see all the little bubbles at the top there from all of our reactions. So, and now that we've done this, is the lava lamp, do we need to throw it away or is it fine to just last?
You can just keep it as long as you want. After all this gas has vented off, it will go right back to the same state that it was. So I can reuse this over and over and over again for demonstrations. But so yeah, absolutely. If you make one of these, hang on to it, keep it. Just at the end, let all the gas vent off like this is doing right now with the bubbling, and it'll actually return to its the state it was when we started talking about it.
Very nice. And so when it's at the other state, you can shake it and it makes like big blobs of bubbles like how a regular lava lamp would do. That's what we think. That's a good experiment to do. So and again, like that's why you put the glitter in it, because then the glitter kind of floats around and
another fun thing you can do is you can add some food coloring to this to get different kinds of fun colors.
We should have had green because it's St. Patrick's Day. Austin
Next year.
Austin didn't know. He messed up here. Very good. Okay, that was a fun one. Okay, guys. Oop, there we go. Very good. Okay, sorry, we moved our camera. Okay, so thank you guys so much for joining us. We are going to have Austin back next week, and he's going to do some more experiments. We're going to make all sorts of messes again. And again, we're going to post the instructions and all the ingredients in the comments. So if you guys want to do this at home, you can totally do it. If you do it, we would love for you to take a picture or video and post it in the comments so we can see. If you have any questions while you're doing it, ask us, and we can answer you throughout the day or whenever it is that you're doing this, because you can watch these videos at any point. And then we will also post the ingredients for next week's experiments so that you will have a chance to get all your stuff together and do it with us if you want. So I guess we can take our glasses off because we're not doing any more experiments, so we're not dangerous
Oh,
anymore.
we're starting to fog up a little bit.
Okay, thank you so much, Mr. Austin, for joining us. Thank you guys for watching at home, and we hope you're having a fun day and enjoying your time at home, making some messes, learning about science and all that stuff. And we totally hope to see you out at the. Oh my gosh, I have foam on my nose. It's fine. It's fine. We will see you guys out at the parks again soon. Okay, thanks. Bye. Oh, right there. There it is. It's right there.